Hi everyone, in this video I'll guide you through coding on the programmable CAN node, which is part of our CAN protocol practice kit. We will be using STM32Cube IDE for coding and debugging. Also, we are using vCAN CAN bus analyzer to monitor the CAN messages. Here you can see the setup. The programmable CAN node is powered by STM32F072X microcontroller. It includes inbuilt ST-Link V2 debugger for flashing and debugging. You can download STM32Cube IDE from st.com website. You can also download ST-Link V2 driver from same website. Let us now launch the STM32Cube IDE. We can see the coding part. I am defining the CAN baud rate value as 500 kbps in the form of a macro. I am also defining a simple structure to store CAN message ID, data bytes and DLC. Coming to main function, we first use inbuilt library functions like HIL init, system clock config, GPIO init and CAN init. In CAN initialization, we have to set prescaler value as per desired baud rate. For our 500 kbps baud rate, we are selecting prescaler BS1, BS2 and system clock values as shown here. Then we are invoking the CAN HIL start library function. We are also enabling CAN error notification setting to catch possible CAN errors. Coming to while loop, we are using CAN message data bytes as hard-coded values stored into an array of 8 bytes. That is, we are preparing a test message to be sent out. We are also fixing the CAN message ID as 11-bit type with value 0x123. The data length will be 8 bytes. Now, with intended CAN message being ready, we now use the library function HIL CAN add TX to transmit our message. We continuously send out our message with a delay of 1 second. The delay is achieved using HIL delay function. I am using a value of 1000 milliseconds. You can modify this value as you desire. Now we can compile our code using build option or hammer icon in the IDE. As you can see, we are not facing any compilation errors. Hence, we can now move on to download the code into the STM32F072X microcontroller using the run button or run icon of the IDE. You can notice LED blinking on the board during downloading and also download successful message in the IDE. Now connect the CAN bus analyzer to the USB port of your computer. Ensure that CAN high and CAN low pins of the board are connected to the corresponding pins of the vCAN CAN bus analyzer. Now open the vCAN GUI and select the baud rate in config tab. Then go to monitor tab and click on start button. Now you will start observing the CAN messages received every 1 second as selected in our code. You can notice message ID is 0x123 and DLC is 8. If you desire, you can select fixed view option in the GUI where you will see the recent instance of the CAN message. You can modify this sample code to suit your experiment or requirement. You can modify the message ID, DLC data values, etc. You can also experiment with different baud rate values by changing the macro value. Thanks for watching. Have a great day.